Hey everyone, welcome to this episode of the Sim Step Up series. My name is Brian Zayas. Today I want to share with you how you can be more productive with linear static analysis using our Simulation Professional product. Again, the goal of today's webinar is to help you be more productive. That means whenever you're running even a basic simulation, giving you just the tools you need to minimize your pre-processing, solving, and post-processing time, as well as helping you get more results and better results faster. Now, if you're already using the Simulation Professional, that's that mid-level simulation package that we see in the blue here, that gives you other analysis types. For example, doing long column buckling, thermal, long cycle fatigue, as well as the optimization tool and potentially frequency. And if you're like me, 90% of my analyses were always linear static, looking at that yield factor of safety, and then maybe once or twice a project, you just need to do some quick validation that the frequency is right, or the thermal situation is going to be okay, or that buckling is not a concern. So what I want to tell you today is that Simulation Professional is actually a great set of tools that I wish I would have had when I was doing linear statics, because it's not just about analyzing 5 additional failure modes, but the Simulation Professional toolset also enables a basket of what I like to call assembly productivity tools to help you get results faster and better and save you time. So in today's web episode, what I want to do is go through these 8 items and tell you about how SimPro can increase your linear static productivity. So let's get going. First up, optimization. Now we have another episode in the same chapter that Omar is going to take you through optimization in depth, but it's one of those things that helps you narrow in on the right design faster. So for example, here I want to minimize the mass of this casting. So I set as variables the rib thickness, maybe a diameter, and then I'm going to monitor the weight as a goal. I'm going to use a design of experiments to go through and set all these parameters to a level where they meet my constraints. So for example, factor of safety being above 3, but the weight is minimized. So obviously this saves us time, because if we're using linear statics, trying to optimize our design for either weight or volume in the case of this casting, this obviously saves time. We don't have to go back and forth to the model and then go back and solve it and then check the results. So here I'm analyzing 15 studies, really just in a few minutes, and getting that optimal design for weight. So optimization, what we call shape optimization, it's awesome. Helps you explore different shapes, different parameter sizes, even different materials as of a few years ago. So again, check out our other Sim Step Up episode that's going to get in depth into our optimization tool. But basically, set up, evaluate any number of dimensions, up to 20. I've never even set that many up in a single study, and then goal for the optimal. Now, another tool recently added in the last several years is 2D simplification. 2D simplification lets me do plane strain or plane stress, or in this case, axisymmetrical as we see in the image, and greatly reduce the solve time. And great examples of these would be any kind of axicylindrical gasket. Sliding problems can usually be done in 2D. And then what I get is a force or a pressure per unit width. One example I have here is a 3D model of a gasket lid that's sealing, probably under pressure, maybe an autoclave or something like that. And of course I can run the full solid mesh. But to get the contact stress I need in the gasket, I'm going to use almost 100,000 elements, and the solve time, since it is large displacement, is about 43 minutes. So of course we all know in linear static analysis there is the axisymmetric or cyclic symmetry boundary condition. So I can run a slice of this, reduce that solve time, and get an answer. Or for the most complex problems where I really need to get a fine mesh and it is axisymmetrical, I do a simple slice, and you can see this one solves in about 3 seconds. And I also have good enough mesh to make sure I get a couple elements across that gasket thickness. I also am able to pull out pretty much the exact same results, as well as representing them in 3D. In this case, I want to understand the contact pressure in this gasket sealing to make sure it's going to contain my gas. A couple more examples of 2D simplification problems. On the left-hand side, a latch sliding. Again, great chance when we have a lot of contact we want to solve to significantly reduce the time just by using 2D simplification. On the far right, a forming, this is a nonlinear problem in this case due to the large deformation as well as the permanent set in the material model, but still a good example of 2D simplification. In the center, a quick linear static or maybe buckling analysis of this drainage tube. So 2D simplification, all about solving axisymmetric or plane strain or plane stress situations in a significantly lower amount of time. Now, the third tool I like to mention is a connector type. Of course, we learned all about connectors like bonded and no penetration. The edge weld is a type that helps me get the stress results and the factor of safety results out for my welds if I'm doing metallic welded parts. Inside SOLIDWORKS, I'm looking at the displacement and stress results, and you can see there's these rings where I'm going to have these fillet welds. The weld connector, when I set it up, enables me to do an immediate factor of safety check on those welds. So instead of extracting the interface forces between my components here, quick factor of safety is basically going to do that throat size and force calculation for me and give me a super quick heads up, green, red, go, no go. Obviously for reporting, this is awesome, as well as of course saving me a bunch of time doing those hand calculations. A couple limitations of this though, it has to be a shell mesh, which we'll talk about in another episode. But again, if you're doing big welded structures like this, you're probably doing shell mesh anyway. And it also really works best for fillet type welds like this. So basically virtually connect your welds and automate some of those tedious calculations we have to do and give you some pretty cool graphical results. Another great time saver is the Toolbox automation that we see in Simulation Professional. And this is great if you're doing bolted structures and you spend a lot of time both suppressing the bolts on the assembly side and then going ahead and creating the virtual fasteners inside of simulation. So what this does, if we take a look, is gives you the prompt and the option to take your Toolbox bolts and convert them into bolt connectors. So in this case, I had 40 of them in this piping and flange situation. What's nice is it sets it up all ready to go with the proper bolt type and sizing and material. So again, a huge time saver versus going through and automating that. If you're not using Toolbox fasteners, if you use the assembly whole series, you'll have a similar prompt after you create one bolt to propagate that around. So a couple little time savers built right in. For example, if we're going to design a splice plate, I can really set this up and answer the question, what's the best splicing situation? And what's nice is when you use the bolt connectors, just like the weld connector, I also get a nice red, green, go, no-go factor of safety. Now you can also look at the fastener forces. Instead of having us calculate the factor of safety, you can pull out the pin or bolt forces and look at the bending, tensile, and shearing stress and do your own calculation. So there's a lot of benefit of using bolt connectors besides just solving faster. And of course the pre-processing automation and Toolbox automation saves you all that time setting up each one of those connections. Another really neat enhancement that we added a few years ago saves me time because I don't have to create a huge mesh just to get a couple key components solved, and that is submodeling. So inside this linear static analysis, I'm going to take a look at the stress, and I see that the biggest response in my system is in the lateral cross member here that we see with about a 1/4 inch of displacement. I'm going to create a submodel study and then pick just the pieces that I want to include. Now, those pieces have to be bonded to the other pieces so then it can transfer the boundary conditions from the master assembly. So now, of course, what I can do is crank up that mesh and make sure that I'm getting converged results on just these critical response pieces. It saves me a lot of time because now I can crank up the mesh and just solve and iterate on either a mesh convergence study or some design geometry right on that small piece where I know the critical response is instead of at the entire assembly. Another example of submodeling is a frame. Here I want to converge on the best geometry for this lateral piece of frame, and what I can do is actually just change the geometry. As long as I still maintain the bonded connection, interface geometry is the same, I can iterate on both the mesh and the geometry and come up with the best idea. So this works obviously for very large structures as well as very complex where we need a tight mesh. For example, I find the critical junction in this steel structure and I want to go in and add more detail to it. I'll basically snip it out. Or I want to look at the leads on this integrated circuit chip package. Great, let me take that out after I run my thermal displacement, for example, and crank up the mesh and see if those leads are going to come off the board. Right? So basically a magnifying glass transferring the boundary conditions for me and being able to zoom right in on my areas of interest and make sure that I'm getting that final answer as fast as possible. Another benefit that's included in Simulation Professional is the Materiality portal. And we all know in SOLIDWORKS there is a material library, but sometimes it's not exactly the material you have. And so honestly, I remember spending a lot of time going onto Google finding what the material properties are and creating my own material. Materiality, if you have Simulation Professional on subscription, you get a simple click here button. You can go search there on an online library of thousands of materials and then bring them right into SolidWorks. Someone told me there's over 100,000 materials. I haven't explored them all, but obviously you can hopefully find a grade of material that's close to what you're looking for from a reliable source, not just a Google search. Also, if you get into nonlinear analysis or you're looking for SN curves for fatigue, you'll find that on Materiality as well. Another great time saver is the load case manager. If you have to run multiple load conditions or combine combinations together or have weighted combinations of your loading, like in a civil structure, or example from my past was we did a frame which was going to go on an airplane, so it had to do several different G loadings in a static sense. It had to do 9 Gs forward, 4 Gs up and down, a lateral analysis, as well as worst case combinations. So the load case manager lets me basically programmatically set that up with just one single static study. So I create different loads or different force entities on my boundary conditions, and then the load case manager gives me this nice table where I can set up what my primary load cases are, as well as add combinations, just like I was in Excel adding different cells together. I tell the software what results that I want to monitor, and what's nice is then I get my maximum stress, my maximum displacement in each direction. I get that all out in a nice, easy to read table, so I can either put that in my report or again understand what the worst loading case is going to be, so I can use that for my design iteration. So super easy to use interface, and as well as looking at the results. A great productivity tool if you have different load conditions or different load combinations. Now, another time saver that we have is the contact visualization plot, as well as the detect unconstrained bodies. Now, contact visualization is important because we all know from the lesson on contacts, you can spend a significant amount of time setting up bonded conditions or no penetration conditions. And one of the frequent reasons why studies fail when they get to the solver is something's not stuck together. So contact visualization, it's kind of like a sanity check before you go to the solver to see what exactly you've set up and what this computer is seeing that you've set up. We'll use the contact visualization plot to show me where my bonded contacts are and where my no penetrations are. Again, validating that everything's going to be stuck together, and I haven't inadvertently set up something as no penetration that could be bonded. So great for new users and, well, seasoned users alike, especially as you get into more and more contact sets. So I can analyze the entire assembly at once or just pick a few parts and see how they're interfacing. Again, validating I've set it up right, making sure I didn't forget anything. These linear static productivity tools I'm a big fan of. They help the setup, they help me get better results, and of course just get better analyses with more valuable results. So if you don't have Simulation Professional, I highly recommend taking a look at it just for some of these tools, and of course you get those other failure modes as well. And if you have Simulation Professional already, definitely check some of these out. Right away, I think everyone can get really good use out of the submodeling and the contact visualization. Those are my top 2 favorite. So I hope you learned something today, and check out the next episode of the Simulation Step Up series. Thanks.